Okay, well, I've just finished this new cinematic build and I've got some major problems with it. First of all, I've got Jello like it's going out of fashion. Whether I'm in forward flight or just trying to hover, it's really bad. I can't hold altitude in forward flight. It keeps on rising and falling as I hunt around trying to find the right throttle position. Hell, it doesn't even track straight when I'm flying straight and level. It's always twisted a little bit off to the side. But that's okay. We're going to fix all of these problems and more in this video. And it's got absolutely nothing at all to do with PIDs or PID tuning. It's all about basic transmitter and quad setup. Okay, so let's take a look at what we're going to do to solve these problems and what we're going to cover in this video. We're going to break it down in 4 parts. First part is transmitter setup. The second part is basic quad setup. Third part, prop selection and testing. And last of all, we're going to delve into some beta flight settings just to top it off. First, transmitter settings. No one likes transmitter settings. It's boring. So let's do it first and then it's done. And the first thing we're going to look at is trim tabs. These 4 switches here, just make sure that all of them are in the center. See, this one here is a little bit off to the right. Okay, nothing is going to affect your flight more than having one of these that's not centered. There we go. Okay, so the next part is stick calibration. Now, a word of warning here. If you've already set extended limits and if you've set your min, max and midpoints for different models, when you do stick calibration, you're going to have to do that all over again. Okay, so if you've just bought a brand new transmitter, then calibrating your sticks is a really good thing to do. And that's why I'm going to show it to you with this transmitter here. Now, the stick calibration is over here in the hardware menu. So we just come down to calibration and it says enter the start. So we just click on enter. We set the sticks to the midpoints, hit enter again. Then it tells us what to do. Just move the sticks to all the 4 corners, center them again, and we're done. From there, the next thing we're going to check is our ADC filter settings. And we want to disable them. See, ADC filter settings are important for aircraft guys, where you want to filter the signal from the sticks before it gets sent to the transmitter. In the case of a drone, we've got a flight controller that handles all of that. So we're going to disable the ADC settings on the transmitter and let the flight controller handle that. And for the ADC filter settings, we're going to go into transmitter menu and we're just going to page across until we get to the hardware menu. And then we're just going to go down. Okay, and here it is here, ADC filter. Okay, I'll just move off it so you can see it there. And it's actually unchecked, and that's exactly what we want. Okay, so the next thing we're going to do is set Elimits, extended limits on the transmitter. And that's going to allow us to set the minimum, maximum, and midpoint for each of the 4 channels from the sticks. And the reason this is important is because the flight controller expects to be seeing a PWM frequency of 1000 at full deflection one way to 2000 full deflection the other way from the sticks. So we're basically going to align what our transmitter is sending to what the flight controller is expecting to see. This is how we do it. Okay, so we're connected to beta flight and we're just going to look at this one here, the rudder, and we're going to do full deflection one way and full deflection the other way. One thing to look at is your channel map over here. So we can see that your is actually rudder and rudder is here. Okay, so it's the 4th channel. So when we go to the transmitter settings, we're going to be looking at the 4th channel. Now we're connected to beta flight and we're going to look at the yaw channel. So you can see if we go all the way to the left there, we're seeing a value of 989. And if you go all the way to the right, we're seeing 2012. So basically we want these values to be 1000 here and 2000 here. So that's what we're going to look at. Right, let's have a look at how we do it on the transmitter. So we go into the model setting and then we just page over till we get to the outputs. Okay, now if we go down here, you can see that channel 1, 2, and 3 have already done them. Channel 4, this is the rudder. Let's have a look at that one. So this is a mini transmitter, so we're actually going to have to go into the menu and edit it to go into here. Okay, the first thing we're going to do is we're going to set the min. So we're going to grab the rudder stick and we're going to move it all the way down to the left. And you can see there we've got 989. Okay, so we're just going to edit this. And we're just going to move it. If you don't know which way to move it, you can just move it one way. You can see it's coming up to 1,000. Okay, we'll just set it, it's gone a bit too far. We'll set it there at 97.8. Okay, once again, going all the way to the right, this is going to be the max deflection. And we're showing in Betaflight, we're showing 2012. So we're going to wind that back a little bit on the transmitter. And we're going to go back 2000, and we're going to set it exactly at 2000. Now the last thing we're going to set is the midpoint. So that's actually the sub trim here. You can see in Betaflight there we're bouncing around 1503. So we're just going to wind that down a little bit. There we go. We're holding steady at 1500 there. Okay, so there's the settings we need. So we've got it set at 1500 in the middle, 1000 on left deflection, and 2000 in right deflection. Okay, so that's the boring part done. Transmitter's all set up. So let's move on to the basic quad setup. And in basic quad setup, I'm just going to take you through my process of setting up a cinematic drone. We're going to look at the accelerometer, the calibration of the accelerometer. We're going to also look at ESC settings, some basic ESC settings. We're going to pull some black box logs and just check the frame to make sure we don't have any resonance issues. And once that's done, then we're going to get onto the important part, which is checking the camera alignment. And this is what's going to help us with tracking straight when we're flying. So first we'll jump into Betaflight and have a look at the accelerometer and ESC settings. And this part is so basic, I almost wasn't going to put it in the video, but calibrate the accelerometer. Just put the quad down on a nice flat surface, go to the setup tab and hit calibrate the accelerometer. This is going to make a huge difference. You've got to have your quad set up and calibrated correctly. Okay. For ESCs, I always want to run a 32-bit software. So at the moment you can see this one here has got BLHeliS installed. So we're just going to flash all the ESCs. And I'm just going to upgrade them. In this case, we're going to choose obviously BlueJ. And for the version, I'm going to just choose the latest version. And PWM frequency, for cinematic work, I'm always using 48. And in Betaflight, that allows us to come down here to the Motors tab and enable bidirectional D-shot and do our settings accordingly. Another thing I like to do is just check a black box log to make sure there's no frame resonance coming through. And to do this, just make sure that you've erased your flash, just to clear the flash out. In my case here, I've got mine set to 4 kHz. If we go up to the configuration menu, you'll see why. I've got the gyro update frequency is 8 kHz. Okay, so I'm always setting it to half, or I try to set it to half what the gyro update frequency is. And of course, for the debug mode, you want gyro scaled. So once that's set, you can get out, do a flight, a quick flight, and then pull some logs and have a look at the black box logs. So with the black box logs, all we're doing is a quick check just to make sure that there's no adverse frame resonances. Let's take a look at a few examples. Okay, so in Black Box Explorer, we just want to go down to the debug plots, and we'll just click on one of them, gyro scaled. And we bring up our plot here. Okay, so just taking a look at this one, even if we go to the pitch axis, we don't see a lot of resonance or noise. If however you see something more like this, let's have a look at this one, maybe on the pitch axis, and we'll just maximize it there. Okay, so here we're seeing a little bit of frame resonance. Don't worry about anything down here below 100 Hz, that's just this motor noise. But this one here has a little bit of frame resonance, so maybe this is something you might want to go and have a look at before you proceed. And if you do have any resonance showing up, there's a few things that you can check. There's very simple things, for example, the motor screws. Tighten up all your motor screws, make sure they're tight. And then next is the props. Make sure that none of the props are damaged or bent. Make sure you've got new props on and your prop screws as well. Moving on to the stack, just make sure that the stack is not able to be rubbing up against any of the standoffs, or there's nothing touching the stack that might be introducing some resonance and vibration into the stack there. Finally, just all of your appendages like the battery connector, this random connector here, even camera mounts, things like this, just make sure everything is secured properly on the frame and everything's tight. And with that done, the next thing we want to look at is camera alignment for the 4K cam as well as the FPV cam. And this is actually a problem I've got with this drone. Let's take a look at a sample video and we'll see if we can see what's happening. So in this video, I'm lining up on that pole down the end of the field there, and you see as I'm going, I'm sliding to the right, slipping to the right, and I feel like I've got to correct and turn to the left to head back towards the pole, and then I still drift off to the right. And the reason for this is the alignment of the cam. The FPV cam as well as the 4K cam, they both need to be aligned. So it could just be a slight misalignment of the camera, or sometimes it could actually be the sensor in the camera. The camera sensor and the lens might not be exactly 90 degrees. And I've actually had that happen. So what we have to do is we have to, in Beta Flight, we're going to put an element on the screen to mark the center of the screen. And we're actually going to measure the center of the screen. And what I like to do is use the disarm word. So if I drag this down, you can see that we've got the center marker there. Now I'm just going to put it down the bottom of the screen and position it so that we've actually got the 4 letters DISA and RMED, and the center of the screen is going to be in between there. So I might just move this over. You get an indication of the center of the screen. There it is there. If I just grab it, you can see the center of the screen, and it's coming right down between those 2 letters. Okay, so that's where what we're going to use when we look through the camera to actually mark the center of the screen. So the first thing we're going to do is just put the quad up against the wall. Basically any flat surface will do. Then making sure the quad's parallel to the wall, just use a ruler and measure the distance away from the wall. So the distance from the wall to the camera. Then put a piece of blue tack on the bottom of a pen, and about 2 meters away, just measure it again and put the pen the same distance away from the wall. Now we're going to check in the goals, and we can see here if we look, the pen is off to the left, so the camera is actually facing a little bit to the right. To fix this, we just need to adjust the camera as needed. And then retest by looking through the goggles again. And you can see now that the pen is lined up exactly in the middle where we want it to be. Okay, so with both the FPV cam and the 4K cam aligned properly, I headed down the beach and did some test flights just to try it out. So this is actually very early down the beach in the morning. There's no wind at all. So I basically just lined it up on the point on the horizon and just straight and level towards the point, and very happy with the result. Tracking is now perfect. Okay, so with our camera tracking and alignment set properly, we're now going to move on to prop selection. And in this section, we're going to look at doing some prop testing. And in the process of doing that, we're going to address our Jello issue. Now, when it comes to Jello in the action cam footage, there's 2 main culprits. One can be the soft mounting of the camera itself, and the second one is going to be the propellers. Now, with most modern frames, the camera mounting system is actually quite good. So in this video, I'm going to focus on the propellers. And fortunately, the cheapest part of the quad is actually propellers. So I've got a couple of packs of 4-blade propellers and 5-blade and 6-blade. I'm going to take these all down to the park, swap them out and test them out and see which is the best. And basically, the way I test propellers is I write down the ones I put on the quad on a piece of paper, and then I just point the cam at the piece of paper before I start flying. So let's have a look at the results. Have a look at these 4 videos and just see which one you think is the best. Now you might notice I'm actually showing you footage from the FPV camera here, not the 4K action cam. And the reason for this is that I want to see the worst it can possibly be. I don't want to see the best it can be, because I want to identify which prop is going to give me the most stable performance through the FPV cam. That's going to be the best prop. And from the testing, the best prop is actually the Gemfan D51 5-blade. Let's take a look at the difference between the best prop and the worst prop. So on the left here, we've got the D51 5-blade, and on the right, the worst prop was actually the Dell Prop 2035. That's a 4-blade. Now, I'm not saying that's a bad prop, it's actually quite a good prop, the Dell prop, but it's just not the right prop for this application, for this motor at this KV. And just for reference, let's take a look at the Gemfan D51 5-blade. On the left-hand side, we've got the FPV cam footage, and on the right-hand side, we've got the 4K cam footage from the run cam done. With the Jello sorted out, the next thing we're going to look at is the altitude hold issue. And this is where you just can't get the right throttle position to give that stable forward flight. And you're just constantly adjusting the throttle to try and keep the quad at a certain level above the ground. Okay, you can probably see here I'm just pumping the throttle, but this gives you the idea. So the way we're going to fix this is with throttle scaling. Throttle scaling allows you to get more resolution in your throttle stick, and it works like this. Imagine this is 100% of your throttle stick movement. Now most quads are going to take off around about 30% and fly straight and level at a little bit above that. On the cinematic drone, most of this throttle up the top here is not used. So what we're going to do is we're actually going to cut that off. And the remaining throttle, we're going to stretch it over the 100% of the stick movement. And that's how we increase the resolution on the throttle stick. I'll show you how to set this up correctly so it's specific to your drone. Let's jump into beta flight. And on the OSD menu, we're just going to scroll down to the bottom and we're going to enable throttle position. And just position that somewhere where you can easily see it on the screen. Now we're going to use that to find out at exactly what throttle position the drone takes off. So we'll disarm the drone and just keep raising the throttle gently until it takes off. And just make a note of what the throttle position was. So in my case for this drone, it takes off at about 36% throttle. So what we're going to do now is we're going to start cutting throttle off the top until we get to a stage where it takes off at 50% throttle. And the reason for that is this. Your takeoff throttle position will be almost exactly the same as your straight and level flight throttle position. Now if I want to do a flat turn and I'm going to mix in aileron and rudder, I want the rudder to be in the center. I don't want the rudder to be down here or up here. It's much easier to have it in the center and do that flat turn like this. And that's why I like to have the takeoff point at 50%. Now to adjust the throttle scaling, we're just going to go into beta flight and go to the PID tuning tab. And then we're going to go across to the rate profile settings. And here we're just going to start cutting down the throttle. And I'm just going to cut it down 10% or 20% at a time. And just importantly, make sure you set it to scale. Don't clip it. Make sure you set it to scale so we stretch that 80% over the whole travel of the throttle stick. And we're just going to do this, and we're going to test and then come back and cut it down some more until we get to a point where it takes off at 50% throttle. Now in my case, I only actually had to scale the throttle to about 80% to achieve a takeoff throttle of 50%. Now with our throttle scaling set up properly, the next thing we want to do is come back into beta flight and set our throttle midpoint and expo. Now the midpoint we're going to set at 0.5, which is going to be 50%. And remember, 50% is the throttle position where we're going to hold altitude in straight and level flight. And then we're going to give it about 0.4 or 0.5 expo. And you can see how it's changed the curve here. We've got a nice little flat area in the middle there, which is going to give us even more resolution around that hover point. Okay, and with that, we're down the beach again for a little bit more testing. And we're just going to do a little flight down the beach here. This is actually a beach called Currimundi Beach. It's on the Sunshine Coast, just north of Brisbane. A lovely spot. So we've got the issue with the altitude hold fixed. So we can now just pin that throttle position we need to hold altitude. Of course, the tracking is all set up. That's done. And as you'll see in the video here, there's no Jello. So we've found the right props. We've gone through the prop testing process and found the right props. Eliminated the Jello. By the way, the vision you're looking at here is straight from the RunCam Thumb Pro. So this is not stabilized. I haven't put it through any stabilization software. It's just the raw footage straight out of the RunCam Thumb. Okay, so while you're just watching the video there, if you can, just reach down and hit the like and subscribe button. That's greatly appreciated, and it also helps other people find this video too. Well, thanks for sticking around to the end of the video. This is the process I use when I'm setting up all of my cinematic drones. So I hope you've learned something from the techniques I've shown here. Until next time, happy flying.